So I know this whole unit is really about climate change, but we haven't really talked about it at all. We've focused so much on the carbon cycle, and we've talked a lot about fossil fuels, and we've talked about trends in carbon dioxide and methane, and I haven't even mentioned climate change yet. And the reason I haven't is because a lot of misinformation out there about climate change really doesn't need to be misinformation at all. You really need to understand the basics, because once you understand the basics, then climate change makes total sense. You have things that have carbon in them, fossil fuels, wood. You burn them, which we use for electricity, which we use for driving our cars. And then carbon dioxide comes out. Carbon goes in, carbon comes out. And we've seen the trends over time, and it makes sense. Like, yes, we've had more industry, and we've had more power plants, and we have more vehicles. Like, it all makes sense. And so what we're going to talk about now is kind of what's been happening. And I'm really going to talk about what's been happening so far. A lot of these things will get worse in the future, and we can make guesses and we can make hypotheses as to what those changes will be. But I really want to focus on what is the evidence right here, right now, because I think that's the most important, is to see that this isn't something that's going to happen in the future. It's something that's already affecting us. So the first thing that's happening on Earth, our average surface temperature has been increasing. So I highlighted over here the word average. And I really want to emphasize that word because climate change is not the same around the world. Some places are getting warmer, some places are getting cooler. It is not an even warming. And this is actually why we use the term climate change. So climate change and global warming mean the same thing. Global warming is referring to, on average, the surface temperature is increasing. However, because it's not increasing around the world at the same rate, a lot of people are like, oh, global warming's happening? No, it's not. It's getting colder here. Ha ha ha. Yeah. So scientists have kind of been moving away from the term global warming just because a lot of people get the wrong idea as to what global warming means. So climate change is referring to the same phenomena. It's just we kind of use it to show things are changing. But the thing is, despite some places getting cooler, the Earth is getting warmer overall. We're having a big temperature change overall. So we've been measuring global temperature since 1880. We've been measuring it even before then, but it wasn't as accurate as to what it is now. So since 1880 to the year 2017, since we're currently in 2018, we've ranked all of those years. From the warmest years to the coolest years. So here's the top 10. Depending on how old are you, these top 10 may have all happened during your lifetime. We can see last year, 2017, is ranked number 3. 2018 is currently on track to be number 4. That can change because we still have a couple months to go, but still, it's going to be high up there. If we look at the past 17 years, they're pretty much all the top highest 17 years on record. That's crazy. Now this isn't showing what the average temperature is. It's actually graphing the anomaly or plotting the anomaly. Anomaly means difference from the average. So we've taken the average across this entire time period and we've said, okay, is it hotter than the average or is it colder than the average? So all the years that are hotter than the average are our recent years. Now you look at this, you're like, oh, it's a degree centigrade or a degree 0.69 Fahrenheit. That's not that much. And you're right, it's not. If it's 59 degrees versus 61 degrees, still feels around the same. But this is global temperature, global changes, which means some places are getting a lot warmer than that, and some places are getting cooler than that. To give you some perspective, when we were in the last ice age was about 4 to 6 degrees centigrade cooler than it is now. So only a couple degrees actually made some huge changes in our climate. So don't think, oh, 1 centigrade isn't a big deal. Oh, it totally is. If 4 degrees centigrade means ice age, then 4 degrees warmer, what does that mean? So our average temperature is increasing. Now, because our average temperature is increasing, weather is going off and doing its own thing. So weather patterns are changing because weather patterns are really dictated based on temperature. Temperature is really going to dictate precipitation. So what we're having is we're having more droughts, but we're also having more rain. Essentially, evaporation is increasing, and places where evaporation is already high, such as deserts, it's getting higher. But that rain and that moisture has to go somewhere. It's going to the same places that typically get rain and moisture, but now it's getting more. Now, as you can imagine, for you and me, especially here in Maryland, it's not really affecting us much. But imagine if you're a farmer. You have your specific set of crops. You have your different strains of crops. They're meant for this and they're that and for what have you. But now that's all changing. You're getting drought more days of the year. You're getting rain more days of the year. And that's really going to affect your output. Here's a map of the United States. This is looking at how much our precipitation has changed over the past like 5 decades. And this is again looking at average. So the greenest, the darkest green areas are an increase of precipitation by 15%, and the darkest browns are a decrease by 15%. You can see it's not the same across the United States because climate change does not affect the world the same way. So more drought in some places and more rain in others. Again, huge impacts. Now related to this, I still gave it number 2 because 2 is just saying changes in weather patterns. Taking a look at hurricanes. So hurricanes specifically, there's tons of different storms around the world. You have typhoons, for example, nor'easters. Those hurricanes are storms that are fueled by warm water. Well, if you have a warm atmosphere, those water bodies, the ocean, is going to warm up as well. And hurricanes are made from warm water. So the more warm water we have, hurricanes are going to increase in frequency, so how many of them we have, as well as severity, how hard and how impacting they are. And we've already seen this, right? We're seeing this every single year now for the past 5 years. We've had a huge storm, and then it used to be like that. Hurricanes totally go through a cycle of worse years and better years, but we're seeing more of those worse years back to back. So looking at just these past 2 years, not too long ago, Hurricane Florence. Look at how huge Hurricane Florence is, heading straight on for Wilmington. So I've told you guys once upon a time, I used to live in Wilmington. They were out of school for 5 weeks because of how severe that storm was. Now, Hurricane Michael this year as well leveled Mexico Beach in Florida. This wasn't tornadoes that came through. This was from the high winds. This is from the high waves decimating these communities. Last year, 2017, Hurricane Harvey devastating Texas. So this is happening now. We're seeing this now, and it's not getting any better. So we've got our increase in temperature. We've got our increase or changes in our global weather patterns. Another thing that's happening is our sea ice is melting. And there's actually a lot of different ice that exists around the world. So the first one is glaciers. Glaciers are literally remnants of our last ice age. Our last ice age kind of ended about 10,000 years ago. And glaciers are just the remnants of the ice age. Now the glaciers are found in really cold places. We're typically talking near the Arctic. So Greenland, Canada, Russia all have, Denmark all have quite a few glaciers. And they're literally melting. So here's a picture of a glacier in 1928, and here is, we'll just round 80 years later, and it's gone. You see a little bit in this background, but for the most part it's gone. 80 years and it's gone. This is ice that has been around for 10,000 years. Now you might be thinking, well, this actually looks like a pretty nice habitat. We've got this nice fresh water, we now have more soil, and I don't disagree. I think this will become a really great habitat for organisms. But 1, that water's got to go somewhere. I'll talk about that water on the next slide. But 2, this should just be a wake-up call that, yeah, things are happening. Our temperatures are changing, and we can see that. We can witness that. And that can be some pretty dangerous things to come. Another thing that's happening is our Arctic, so kind of up where our glaciers are melting, and melting fast. Every year, the Arctic gets small in the summertime, and about September is usually when the Arctic is the smallest. And if you're not familiar with the Arctic is pretty much an iceberg, so it's sitting in the water. So the problem is that not only is the atmosphere getting warm, but the water is getting warm. So it's actually melting the Arctic from 2 different directions. So just as a comparison, here's what that Arctic sea ice looked like in 1984. Here's what it looked like in 2012. So really huge differences. This is where all the depressing pictures of polar bears come from, because polar bears are up in the Arctic, and so as you can see, their habitat is shrinking. There's a lot of other species that rely on this ecosystem as well. So thinking about different seals and sea lions, thinking about even aquatic creatures that rely on that sea ice as a food source. So we're having this incredibly shrinking habitat. The other problem too is that sea ice actually helps keep Earth cool. It's essentially like a giant mirror. That incoming solar radiation comes in, hits the ice, which is really bright, really light, and literally bounces it back off to space. But because it's getting smaller, more and more of that sunlight is getting turned into heat and being absorbed by the water, making the Arctic even smaller. So a lot of issues going on. Surprisingly and weirdly, Antarctica is growing, but it's growing unevenly. So some parts of Antarctica are growing and some parts are shrinking. Unfortunately, the parts that are shrinking are typically where a lot of the marine life is. So a lot of the penguin colonies are there on the side of Antarctica that is shrinking. The shrinking side is also where a lot of krill is found, and krill is the really base of the food chain for all the species, the penguins and the whales that exist in that area. But then parts of Antarctica are growing, ice sheets are growing, and it's actually growing faster than it's melting. But what I will say is although Antarctica is growing, it's not growing so much that it's taking into account the Arctic melting. So yeah, Antarctica is growing, but growing really small and growing very little amounts, whereas the Arctic is melting and it's melting a lot, and it's melting a lot more than the Antarctic. So although Antarctica is growing, don't think of it as like, oh, this is a great sign. It's interesting. But it's not going to save us, especially because kind of the most important parts of Antarctica, at least to our ecosystems, are melting. So what's popping up is going to be a link. It's actually a NASA website, NASA video, and it's kind of explaining this weird disparity between what's happening in the Arctic and happening in the Antarctic. It's got some really cool imagery. So go ahead and pause here, take a click at this link that's popping up, and then come on back.